So welcome everyone here today, both in the audience and on the panel here. We're going to be talking about AVSs. And if you're here, you might already know what an AVS is. If you don't, an AVS is an acronym for Actively Validated Services. And these are basically verifiable, decentralized services built on EigenLayer or built on shared security. So with us today, we have a bunch of teams who have built and are either have already launched or are currently launching AVSs on EigenLayer. And to get started, we're going to let everyone give us some intros, and then we're going to dive into what they're building and maybe go into a little bit of a spicy conversation. So to get started, I guess we'll go in order. Just introduce yourself and give a quick TLDR, maybe 30 seconds or less, about what you're building.
Thank you, Nader. Hi, I'm Michael from Brevis. So Brevis is a smart ZK coprocessor. To put it simply, it is a new way to scale your on-chain computing to an off-chain environment. Right now, everyone's smart contract computation is constrained on-chain resources, but on-chain has some fundamental limitation of consensus. Therefore, how we do this is you can migrate your computation off to the off-chain environment and at the same time generate a zero-knowledge proof. And you can use that proof directly back to the blockchain and verify it on the blockchain. So you can tap into very, very complex computation, data-heavy use cases.
Good afternoon, everyone. Thank you for having me. Thank you for having all of us. My name is Ismael. I'm one of the co-founders of Lagrange. We also build a ZK coprocessor, so I guess we're a bit competitive with Brevis there. The main structure of our coprocessor is with verifiable SQL computation. So we are able to scale the types of things you can build on chain by being able to lift off data-heavy computation, things like queries over large amounts of historical data, receipt data, transaction data, to an off-chain environment, and then verify proofs of that back on-chain. We work with a lot of protocols like Gearbox, EtherFi, Azuki, and some more to be announced soon.
Hey everyone, Deli from Automata here. We're building multi-prover AVS on EigenLayer. A multi-prover is actually a kind of a new way of accelerating all these rollups into stage 1 and stage 2. I think Vitalik also mentioned this kind of concept during his talk today. So what we're doing is actually using trusted execution environment to help like ZK rollup and also optimistic rollups to enhance their security. Essentially re-executing all the blocks within TEs, and we present a different proof in the TE format and get it verified on chain. So far we're working with Scroll and Linea. We are official partners building the multi-prover for them. Also, Tycho and ZK Sync, we're in conversation with them. I think they're using our attestation libraries so that they can verify everything on chain.
Hey guys, this is Eskil from GoPlus Security, and GoPlus Security is the largest user security network working on protect on the end user. And we're starting to build the user security data since 2020. And if you nowadays go into DEX tools, DEX Screener, CMC, Jacob Terminal, EtherScan, like any of this data website or many wallet, SushiSwap, you can see if there's some asset or address was labeled by GoPlus with some malicious function, like not open source, like a honeypot or like a balance changeable, this is all provided by GoPlus. And we are also starting to build a user portal, which is trying to become a user security module to provide a firewall to all the end users on different chances. And since this year, we're also very proud to announce we are starting to build AVS on the top of EigenLayer to decentralize our computer layer here. Thank you.
So I've been to a lot of boring panels this week, and I want to know, like, if we can spice this up a tiny bit. So before we kind of get into the nitty-gritty, I would like for everyone to give a one-sentence spicy take about the current state of Web3. It could also be a one-sentence, like, highly optimistic, bullish take, either one or the other. So I guess we'll start again with you.
Sure. I guess one contrarian take is that we don't. Everyone says we have an adoption problem and we need to have consumer applications. Or we won't find kind of a product market fit for crypto. I would argue that we don't have a product market fit problem. We actually just have a regulatory problem.
I like that. That was controversial. Yeah, so mine is hopefully controversial, hopefully also intuitive. I think private capital in crypto is oversaturated. I think just private rounds being done at valuations that make no sense. And I think public liquid markets are undersaturated. There's not enough institutional purchasing of liquid assets.
Okay, I think my take is, it's actually about the tech. I'm witnessing some of the accelerations in the TE space. In yesterday's TE Salon, tea time, one of the presenters actually shared that they are building some open source chips that has TE capabilities. So if that gets shipped in 2 years, a lot of infrastructure is going to be running on TEs.
Yeah, I heard some word and pretty agree because someone has described the Web3 or crypto nowadays as more looks like it before the Windows 95. So we're probably in the late 80s or the early 90s. So what our situation? We have some application, we have some infrastructure, but everything is like in the very early stage. And we are struggling climbing on the infrastructure and also hopefully having some more meaningful depths, but it's probably taking some time. So yeah, I pretty agree with that.
Bullish. Okay, so the next set of questions is going to be around unique characteristics, use cases, and applications that can be built using your AVSs. So I guess the question is, what are the unique use cases or products that can be built with your AVSs? And let's maybe start down at the end with GoPlus.
Yes, thanks. So I have already made a short introduction. So GoPlus is started to build this user security network since 2020. And right now, we already become the largest data provider and build our own channel. But one thing we learned from Web 2 is actually you cannot make another censorship in security level on your own. So we are trying to find this best solution to decentralize ourselves for a very, very long time. But before Eigen layer, we also listen a lot from Mojo blockchain. But I think AVS nowadays is kind of one of the few things we can really utilize to decentralize ourselves. So the idea is we are putting, because the idea is like we are building this firewall, but this firewall is not completely provided by GoPlus. We will encourage developer to building the security application or service on the top of us. So we're trying to frame that into the Docker, and we let the AVS, the validator running the Docker to make sure everything is transparent, is open. But this is actually quite different from the most popular AVS applications like DA or other DeFi thing because the security data is a little bit different from like the financial data. But I think this is a great try, and we're also bullish to utilizing this. We have some always have some questions, challenges, but we also have the answer for the moment. So I think it's going to be a very exciting and long journey for that. I've stopped there.
For us, I think at the moment, I mean, our AVS is really just called like multi-prover AVS, so it's really straightforward. We're trying to onboard more and more rollups who really want to adopt this kind of approach. But I would like to also share some other like development that we have so far. I mean, that could be also like running as an AVS, or in the future we can kind of transition ourselves into a more general purpose like TE coprocessor AVS. So one of the things that we are working with WorkCoin is actually some MPC and TE effort. So what happened now is WorkCoin is actually doing like uniqueness checks for human beings. They're doing this iris code scan and trying to detect whether this new scan has been seen before. So this is more like a membership uniqueness check. So they're actually exploring using MPC first to do this check so that not a single party would have the possession of like maybe the secrets of this kind of iris scan code. But the next step they are trying to do is trying to put this MPC protocol into TE environment so that each of the party wouldn't be able to collude with each other. And more interestingly, because their algorithm and the data that they handle is so huge, so that they have to use GPU for this. So they are exploring using NVIDIA's like latest like chip H100 to do this. And good news is this chip comes with TE functionalities. So eventually we will see like this kind of MPC plus TE setup. And we'd love to explore also like other use cases, maybe in custodian and in other like very like some of the consumer applications too.
Yeah, this is a great question. So one of the things that really kind of took me aback by 2049 this year is kind of the increase in application level builders that I'm seeing in the space. There was actually a really good piece by Ishan on the Eigen layer team this week about what he was calling intelligent DeFi. This idea of a next generation of on-chain applications, in particular DeFi, that are being built with an awareness of the infrastructure primitives that the industry has been spending the better part of 2 years innovating on. And this generation of new DeFi applications are built with these novel mechanisms and novel features that from the ground up were not possible before. This is stuff like loyalty and rewards programs directly embedded in on-chain applications, VIP tiers. This is things like new architectures for yield-bearing or incentive tokens. The types of things that we know empirically have attracted and retained users in Web 2 counterparts that we can now embody on-chain. And so this is something that I think, as we're layering infrastructure on infrastructure on infrastructure, we're finally seeing the breakthrough at the application level.
Yeah. So just want to build on top of that, right? So like why this thing needs a coprocessor like Brevis, for example, is because over time when we scale up blockchain, we're still scaling up blockchain in the form of a blockchain. If you think about it, we have layer 2 blockchains, alternative layer 1 blockchains. So as long as it is still a blockchain, it plays within the trade-off space of a decentralized system. Now, what is the nature of the decentralized system? It is replicated storage and replicated compute. So what that means is that the fastest blockchain you can have cannot exceed the computation power of a single server. And that's really limiting. Now, what Brevis enables here is to allow you to jump out of that constraint and allow you to actually tap into off-chain computation resources, and you can actually tap into that resources in a parallel and concurrent way to increase the capacity of computation that is available for your smart contract. Now, one example of that, why we couldn't do things like trader loyalty program in the past, was because if we want to do that, we need smart contract to have the capability to access historical trade events. Now, what that means is that you need to do a bunch of Merkle inclusion proof on-chain directly, which turns out to be very expensive if we're running in this replicated compute and replicated storage environment. But if we move that exact same computation off-chain and generate a zero-knowledge proof for that, because we're essentially moving a computation from a high unit cost environment to an extremely low unit cost environment, and then bring it back to the blockchain for verification, which is very, very cheap computation. With that, you open doors for a lot of more computation power that allows you to deal with this data-heavy and data-driven use cases, such as in DeFi, for example. We already have use cases with Quanta that is live, one of the biggest perp aggregators that are doing VIP fee rebate that is already seeing amazing increasing in market efficiency because we're essentially doing market maker rebates using this type of data-driven features, and many more will be launched as well.
So TLDR, I guess, would be compute off-chain, verify on-chain. I think really I saw a hat or a shirt that said that I thought was really nice. So two more quick questions, and then we'll be wrapping this up. And if someone was to kind of ask you, I'm asking this question because I think I'm still meeting people who don't understand Eigenlayer and they don't understand what an AVS is. So if someone was to ask you, what is the 15 to 30 second TLDR of what an AVS is, what would be the answer? Maybe I can start here with you.
I think Eigenlayer, to put it simply, is a way to build proof of stake system quickly with the security level of Ethereum stakes. So,
it's a marketplace for trust. It's a way to use a large existing pool of economic security with a low cost of capital to bootstrap new types of middleware or things that service the Ethereum ecosystem.
Okay, you guys already had two answers. I had to find something different. I think AVS is actually a orchestration layer trying to match the compute demand from the supply. So we actually have a lot of, most of us have a lot of supply so far, but maybe we should look for more demands.
Yeah, I was thinking about trying to explain in the simple word. I think the biggest sense of AVS is really lower the barrier and the cost to build the proof and layer of the consensus. And also another thing, maybe in the future, I really inspired by the speech like Robert and Sarah made, like converting the cloud into crypto, is also, I think that's a possible way to adopt more application into crypto in the AVS way. I think it's a long way, but I think it's very exciting.
So this will be the last question, then we're going to wrap it up. I'm sitting here with four of the top experts in the world around actually building an AVS, having been there for a long time, and you are now have gone through a lot of work and time and have kind of maybe gotten through a lot of the challenges that maybe a new developer would run into when they're joining. And maybe we've solved some of those challenges, but there's still a lot of unknowns when someone gets started building. So if you had some quick advice for a new developer or a new team building their AVS, having gone through everything that you've gone through, what would be the advice that you would give them? And feel free to just jump in, whoever feels like they want to contribute.
I can jump in. I would say start with a problem. Look at the space, see something that you think is missing that you would need to build something that you'd want to use, and then build an AVS to solve that problem. I think we're getting to a point in market where infrastructure is not going to be as readily funded as it used to be. But good infrastructure will always find funding and will always find usage. So start with a problem, talk to your users, develop alongside your users, and then commercialize something interesting on top of EigenLayer.
I'd like to continue what Ismael has shared. I mean, after you identify the problem, after you start building AVS, I think next thing is try to figure out what's a measurable security that this solution gonna have or this solution gonna need, because that will impact like how big it's gonna be the market and also how much TVL or like stake assets you eventually need. And by doing that, you will figure out maybe this vertical isn't really like a good fit because like it's hard to quantify. But if you really find something that's good to quantify, it's going to be very straightforward because you could create a formula that like directly routes like whatever you need into the supply you are trying to fill.
I will start with some questions or challenges because we do have a lot of questions and challenges when you're first starting to build this AVS. But I won't be specifically talking about that. And it's about like the way of the how to build it and also like the way of the slashing for the validator of a whirling system. And right now, I think we are more focusing on really how to do that when we're really starting operating that. But I think the most important thing is if you really want to pick up something which is capable and with really long term, you have to jump into this anyway. So you better just to come and just to learn like facing any kind of business problem your project will facing on and trying to learn about it because there are already so many good cases like built by EigenLayer, AutoLayer, or Santic. I think there's some good cases. It's still updating, but I think it's really interesting. It's fascinating. It's more sophisticated than like the things we've seen before in crypto, but it's actually a very, very interesting system itself already, like for the developer on that. So definitely worth to try to do.
I mean, just to sharing more from kind of a product and also technical point of view, right? So like EigenLayer is an extremely open system and environment. You can build whatever proof of stake system you want because it can leverage the raised stake security. But you need to think about building EigenLayer AVS as two parts. One is the on-chain logic of how your stake works, how the distribution of the rewards, how the slashing works. But the second part is actually very much intertwined with the on-chain part, which is like off-chain logic and off-chain business logic of how you operate an AVS. What does this AVS do? Do you have a separate consensus versus like just using a aggregator circuit signature to actually verify the consensus? So that part of the kind of a stack or that part of the engineering stack need to be really thought through. And in the beginning, there weren't a lot of references on that. Fortunately, we were one of the kind of long-term backend builders, so that was fine for us. But we have been hearing from different teams the feedback of having some reference like that. For that, I would very much suggest you guys to look at the EigenLayer template that is being released by the EigenLayer team, which is giving that type of reference, giving that type of roadmap will help you to bootstrap that quickly.
Well, thank you so much for your time and for the great conversation. And anyone else that has any questions, some of us will probably be outside taking additional questions after this. So thank you.
Thank you, everyone.
Thank you, guys.